today's lesson has a little bit of yesterday's in it too. So we're not going to work every single problem. We're just going to talk through some of the stuff, and then I'm going to show you actually a different way that we could have done some of them yesterday, but I chose to split it up like this because you can do it both ways, and I don't want to do both ways in one day, basically. Okay, so if you remember your rules, you can never leave a radical in the denominator, and you can never have a fraction under a radical sign. So is this situation right here okay? Yes, this is fine, okay? What about this? No, can't do that. Can't leave it like that anyway, right? Can I leave an answer like this? No, okay? Can't leave a fraction under the radical sign either, okay? So in example 1, we could do it exactly like we did yesterday, but we're not going to. We could start by just rationalizing the denominator. Totally works, absolutely nothing wrong with that. But what I didn't show you yesterday that you can do is, since you have, everything that lives under the square root lives in the same world, right? I can rewrite this as the square root of 27 over 3, which I can't leave it like that because that's one of my rules, right? But then what's 27 divided by 3? 9. So then this becomes the square root of 9, and what's the square root of 9? 3. Okay. So it makes this particular question a whole lot easier, but it's not necessarily going to make everything, not everything you do is going to be able to reduce or anything like. Close your computer, please. All right. So then on example 2, I can't leave it's kind of the opposite of what we did with example 1, is that I can then split this one into square root of 2 over the square root of 9. And then what's the square root of 9? 3. So this becomes square root of 2 over 3. And we're done. Okay? Easy enough? Any questions at this point? All right. On example 3, could we do either one of the things we just did in example 1 and 2? No, because the 2 is not under the square root, so I can't make a fraction out of it or anything like that. This we would just do exactly like we did yesterday. So I think we don't need to do it because we did plenty of those yesterday, right? Same thing with example 4. There's nothing, I can't split it up or put it together, so this would just be, we already did all that yesterday, okay? I just didn't take it off the notes. But let's look at example 5. What we could do, like we did yesterday, but we're not going to, is I could start by simplifying the square root of 24. But I could also go ahead and just make it one big fraction in here and get 24x to the 10th over 6x to the 4th. All right. So what's 24 divided by 6? 4. And then x to the 10th over x to the 4th is what? X to the 6th. And so that is what is under my square root. Because all I did was reduce that fraction on the inside before I worried about the square root. Now I don't even have a fraction. Square root of 4 is 2. What is the square root of x to the 6th? X to the 3rd. And that is my answer. Okay. What questions do you have? All right. Then 6 is just like what we did yesterday. Also, just simplify the square root of 24 first, and then it's all the same steps. Okay? We good on those? Any questions? All right. Flip it over. Okay, so let's talk about what happens when your denominator has 2 terms. So we've been simplifying or rationalizing ones where it's just the square root of 3 in the denominator. If you have plus or minus, you have more than one term, there's a different rule. We have to use what are called conjugates. This is introduced to you in Algebra 2 for the first time. So conjugates are 2 binomials that have the same terms, but the opposite sign between them. So if I have a plus the square root of b, then a minus the square root of b is its conjugate. If I have a plus bi, then a minus bi is its conjugate. You just change the sign in the middle. That's all. So if I have 3 plus the square root of 2, the conjugate is 3 minus the square root of 2? If I have 1 minus the square root of 3, what do you think the conjugate is? 1 plus the square root of 3. Okay, we good on all that? Okay, so let's talk about how easy these things are to multiply by looking at little example using these two things here. If I'm going to multiply a plus the square root of b times a minus the square root of b, okay? So I'm going to take you through something over here in red that we're not going to have to do over and over again. I'm just going to show you where it's coming from. So to multiply these two, I have to do FOIL. So multiply a times a, that's a squared. Multiply the outside 2, that's going to be minus a times the square root of b. Inside 2 is going to be a times the square root of b. Last 2, positive times a negative, I know is negative, but then square root of b times the square root of b is what? B. Right? So then when I simplify this, these two are the same but opposite signs, so those zero out. I end up with a squared minus b. All this is a difference of squares. Remember when we had, if I had x plus 2 times x minus 2, that's just x squared minus 4. Or if you factor it, you get x squared minus 4. It factors into this. Do you see how this is the same thing? And we can skip that step right there. When you're multiplying a difference of squares, you square the first term, then minus, and you square the second term. So here, that's what we did. We squared the first term, minus, and then you square the second term. Okay, so you don't have to actually FOIL it every time. That's all it is. So we need the conjugates because you can never leave a radical under the denominator. And when you multiply conjugates, you eliminate the radicals. So if you didn't eliminate the radical, you didn't actually use the conjugate. So if I have 5 minus the square root of 2, 5 minus the square root of 2, and I'm going to multiply it by its conjugate, which is 5 plus the square root of 2, I don't have to do all these steps over here. I just square the first term, 5 squared is 25, minus the square root of 2 squared is 2, so I get 23. Okay, and that would be my answer. Everybody okay with how that works together? Remember, knocking the cobwebs off, right? Okay, so let's look at example 7. The conjugate here, I look at the denominator, right? That's 2 plus the square root of 3, so I'm going to use 2 minus the square root of 3. And just like we did yesterday, my green fraction has to have a value of 1, so I need 2 minus the square root of 3 in the numerator as well. I'm going to put parentheses around everything that has more than one term. Then when I multiply straight across, I have to make sure I distribute that 6. So that will give me 12 minus 6 times the square root of 3 over, then this is my difference of squares. I square the 2 and get 4, minus I square the square root of 3 and get 3. 4 minus 3 is 1. So my answer is just 12 minus 6 square roots of 3. Okay. Any questions about that? We okay with that? All right, so now on example 8, we have a square root in the numerator also. I don't care about the square root. You can have square roots in the numerator all day long. What I care about is the denominator. So that's got to be 3 plus the square root of 2 over 3 plus the square root of 2. Okay. I'm going to put parentheses around everything with more than one term. Make sure to distribute that square root of 6. So that'll be 6 square roots of 3 plus, what's the square root of 6 times the square root of 2? What's the square root of 6 times the square root of 2? Square root of 12? Yes. over, I square the first one and get 9, minus square root of 2 squared is 2. So that gives me, and then that's going to become 7, right? So that's 6 square roots of 3. Oh, but can I simplify the 12? I can. Let me go ahead and rewrite it. Plus 12 over 7. Oh, not 12. I'm sorry. Square root of 12. What did I do? Oh, shoot. 3 squared of 6. I don't know. I was focusing on everybody that keeps talking while I'm talking, and it's distracting me. Yes, 3 squared of 6. I was making up math. Plus this, no wonder nobody would answer the square root of 12. You're wondering where the heck I got the other thing from. 9 minus 2. There we go. Does that look better? Thank you. That should be, and then that becomes 7. But I can simplify the square root of 12. That can become 4 and 3. And then that is 2 and 2. So that's going to give me 3 square root of 6 plus these 2's come out as a regular 2, square root of 3 all over 7. Okay. Questions? All right, if that 7 was a 2, could I cancel it with that 2? No. You can only do it if you can cancel it from all 3 terms, right? So it's a big fat no-no right there. Questions? Okay. So on example 9, we have basically the numerator and denominator are conjugates of each other, but we don't really care about that. Again, we only care about the denominator. That is 4 minus the square root of 10. So this has to be, oh my gosh, this has to be 4 plus the square root of 10 over 4 plus the square root of 10. I'm going to put parentheses around everything with more than one term. The numerator, I have to FOIL. Okay, there is a rule for it, but most of us don't remember it, and it's just easier to FOIL. So we're going to multiply 4 times 4, that's 16. Outside 2 would give me plus 4 square roots of 10. Inside 2 plus 4 square roots of 10. Square root of 10 times the square root of 10 is 10. Then all over, I square the 4 and get 16 minus square the square root of 10 and get 10. Any questions about where anything came from? Ask me a question. Are you just having trouble seeing, or are you not sure what the heck I did? No. Okay. All right, so this becomes 6 right here, right? And then in the numerator, I can combine the 16 and the 10 and get 26 plus 8 square root of 10 over 6. Now, can I reduce this fraction? Yes, because all 3 terms are divisible by the same number. What number would that be? 2. So if I divide each one of them by 2, this becomes 13, this becomes 4, this becomes 3. So I will get 13 plus 4 square roots of 10 over 3. Okay. Questions? Any questions about where anything came from? You got a question? Sure. We're good? All right. Now, on 10, these are imaginary numbers, but they're still irrational because I is the square root of -1. So same thing, I take the conjugate of the denominator. That's -3 minus 7i, so it'd be -3 plus 7i. You just change the sign in between them. So -3 plus 7i in the numerator here. Parentheses around everything. Numerator, we have to FOIL. Okay? So 4 times -3 is -12. Outside 2 would give me a positive 28i. Inside 2 would give me a positive 30i. outside 2 would give me a negative 70I squared. I'm going to write it like that for just a second, and then we're going to come back and deal with the I squared. All over, then we square the negative 3 and get a positive 9, minus, when we square 7I, we get 49I squared. Okay. What does I squared equal? Negative 1. So before I do anything else, if I squared is negative 1, then that means this becomes a positive 70. If I squared is a negative 1, that becomes plus 49. You with me on what I just did there? Without rewriting it all? Okay. So then I get 70 minus 12 is 58. 28I and 30I, 58I over 58. Can I reduce that? All three terms are divisible by 58, right? If I cancel it all out, will I just be left with I? No, somebody would write that, I guarantee it. But when I can't, 58 goes into 58 once, right? I don't care about the 1 in the denominator, but this 1 right here that gets forgotten a lot is very important. Your answer is 1 plus I. You still have 2 terms in the numerator. Okay. What questions do you have? Are we all good so far? Okay, then I want you to do number 11 on your own. And try and do it like we did today, not yesterday. It'll make it easier. Well, like what we did on the front. Because you don't have 2 terms in the denominator. So basically reduce the fraction first is what I'm getting at. Before you split it into 2 square roots, reduce your fraction. It's going to make it easier.
This is how you simplify it.
Yep, and then split it into 1 on the top and 1 on the bottom and go from there. You got it? Okay, if I simplify, that gives me the square root of 9 over 2x. Do we agree with that? Yes? Then I can make that the square root of 9 over the square root of 2x. Square root of 9 is 3 over the square root of 2x. Then I rationalize square root of 2x over the square root of 2x. So then that's going to give me 3 square root of 2x over 2x. If you just started by if you didn't reduce the fraction and then just rationalize and simplify, that all still works. You just get bigger numbers, right? So you want to try to learn to, simplify your life a little bit along the way without making up math, just so you're not making things harder for no reason, okay? Any questions at all on 11? All right, so now I want you to do 14. We're not doing these other 2 because we're not going to talk about rationalizing like that. We don't need that. If it turns out that we do need that next semester, which I'm 99% sure you don't, we'll come back and do it, but I don't think we need to do it.
Oh, wait, we're not going to do this.
14, no. 14. That is not number 14.
Oh, sorry.
Can you foil the top? Good. Wait, what does this say right here? Where'd 35 come from?
Oh, 30.
Okay, there you go. Then it'll work out much nicer for you. If you're totally stuck, I'll work it in just a minute. But those of you that are working along, I'm going to give you a minute to. Okay, hang on before you get any farther. Was it you that I saw what we're doing? Yes. Okay. When you do these two, you cannot subtract what's underneath. The only time you can combine them is when you're multiplying. So this is like x and y, and you just leave it as two terms, and then simplify it from there. Uh-huh.
How do you? I don't.
Okay, you just there are different. So you square the first number. So this when you square the square root of 10, it's just 10 minus you square the second number. So you'll end up with 10 minus 6.
Oh, so like
That's all it is.
all
For all of those, that's all we did. Yeah, we just squared the first one. Yeah, and got 9. Then we squared the second one. That's what we did on all of them.
Okay, and if it's under square root,
Yeah, you just knocks out the square root. It's not 3 times 6. Oh, it is 3. I'm sorry, it is 3 times 6. But then that's 3 times 2. Yeah, because you're doing so well. Like you're. It's okay. It's the simple stuff. It gets me too. I'm not gonna lie. Okay, if you're stuck, I'm gonna start working. If you're still working, that's fine. And your steps could actually look different along the way, depending on when you simplified and whatnot. But if I'm gonna foil, let me write down what I'll get when I foil. Square root of 30, outside 2 plus the square root of 18, minus the square root of 50, minus the square root of 30, all over 10 minus 6. Do we all agree with that much? That's from foiling and doing the difference of squares. These two zero out. In the numerator, I cannot combine the square root of 18 and square root of 50. That's like x and y. So I get the square root of 18 minus the square root of 50 over 4. Okay, but I then have to try to simplify these. So when I do 18, I can do 3 times 6, and then 6 is 2 and 3. Oops. 2 and 3. And the 50, I could do 5 and 10, and then 5 and 2. So when I simplify them, these two 3's come out as a 3. The 2 stays underneath. For the 50, the 2 5's come out as a 5. The 2 stays underneath. And I have a 4 in the denominator. Okay. So all I did right there was simplify the square root of 18 and the square root of 50. Okay, everybody with me there? Now can I combine the 2 in the numerator? Now I can, because they both have a square root of 2 on them. So this becomes negative 2 square root of 2 over 4. Can I reduce that some more? Yes, I can. Becomes negative square root of 2 over 2. What questions do you have? We're good? And you don't necessarily have to like simplify in it like I am. If you want to go off to the side and do those things, that's 100% fine. I just write real big up here and I don't always have the room for that. Are we good? Any questions at all? All right, your assignment is in Delta Math.